Thank you, Chris. Hello, everybody. This is Ian Burnett from Inseto, and thank you for joining us. Inseto is a leading supplier of equipment and materials for semiconductor research, development, and production, including photolithography, thermal processing, dicing and scribing, electrical probing, atmospheric and vacuum plasma treatment, and the assembly and packaging processes. In addition, we specialize in the supply of high quality silicon, glass, fused silica, sapphire, silicon carbide, SOI, and silicon on sapphire wafers and substrates. Our adhesives division distributes DLO products and offer a very wide range of solutions for bonding, sealing, and encapsulation. Over to you now, David.
Yes, thanks very much, Ian. And hello, everyone. My name is David Williamson. I am the head of science and education at FOM Technologies. Today, I'd like to give a brief overview of our company, who we are, what we do, and how the products we've developed contribute to the advances in various fields of large area electronics research. So we are FOM Technologies, and our mission is to enable high quality, scalable thin film research via our unique lab and pilot scale slot die coating tools. We were founded as a spin-off from the Technical University of Denmark in 2012, where we initially started developing our tools to support organic photovoltaic research. But over the years, our customer base has spread around the world, and our applications portfolio has also expanded quite significantly just beyond just OPV research. And in the last year, we were fortunate enough to become successfully listed on the NASDAQ First North Growth Market. So it's been quite an exciting journey for us in a short amount of time. We're based in Copenhagen, but we've sold our tools to every continent except Antarctica, and we're certainly keen to fill that gap if you know anyone who's interested. We have showrooms in Seattle, Chicago, and Berlin, and we have distributor agreements in the UK and China, and we're working to continue growing that footprint every day. We have both academic and corporate customers with about a 70-30 split between those two groups, and we work with a wide variety of researchers with many different application focuses. Right, so what is it that we actually do? Our company is entirely focused on supplying easy-to-use slot die tools for thin film and large area electronics research. In case you're not familiar with the slot die process, it's a proven technology for scalable production of high-quality thin films with about 50 years of history in commercial production of photographic papers, displays, batteries, and lots of other things. And then a schematic here, we can kind of get an idea of how the process works. So typically in a slot die process, you will dissolve your thin film material into a coatable solution, which is then pumped through the slot die coating head, where it's distributed across the width of your coating, and then exits the slot die at the outlet in the form of a continuous thin film. And in this way, it's possible to produce thin films with thicknesses ranging from all the way down to 10 nanometers up to several hundreds of microns with great control and uniformity. And I think here we can see a small video of me repeatedly coating a 10 micron thick wet film of PEDOT-PSS. This coating is about 1 centimeter wide and 20 centimeters long, but you can of course increase the length just by using a longer substrate and increase the width by increasing the width of your slot die. It's a very flexible process in that way. Right, so how does slot die actually benefit large area electronics research? Firstly, as I'm sure you're aware, many large area electronics research applications depend critically on functional thin films for success. So this includes everything from thin film solar cells to batteries to sensors, displays, and more. But when it comes to the production methods that are available to R&D professionals in these areas at the lab and pilot scale, conventional methods tend to suffer from some significant drawbacks in terms of scalability, flexibility, quality, and process control. So if we look at some of the usual suspects here, we can see that, for example, spin coating is quite cheap and cheerful, but really limited in terms of scaling potential, as well as upper limits on thickness and viscosity compatibility. Blade coating is similarly low cost, but struggles with lower viscosity materials, precise control and uniformity over large areas, and certainly achieving layer thicknesses below 1 micron is a challenge for this technology. And then inkjet printing is another technology that's sometimes used in large area thin film production, but is extremely limited in its viscosity window and also relatively expensive. So in our opinion, that makes this process more relevant, for example, for fine detail printing rather than production of wide area thin films as we sometimes see today. Slot die, by comparison, really has some significant advantages in terms of control, quality, versatility, and scalability when compared with these other lab scale technologies, but certainly has drawbacks in terms of sometimes higher cost, more complex process optimization, and the fact that it hasn't historically been designed for lab and pilot scale research applications. And this is borne out when we try and put some rough numbers on these key performance metrics for these technologies in terms of thickness, viscosity, uniformity, throughput speeds, etc. And we're happy to share this information with anyone who's interested. Right, so the next logical question is, why isn't slot die more prevalent in large area electronics research then? And the answer to this question really comes down to this last point in the lower right-hand corner of the slide here, in our opinion. And that's that the technology has not been historically designed for for lab scale production. It's historically been an industrial manufacturing technique. So if we look at conventional slot die lines as have existed in industry for several decades, they're very large constructions requiring thousands of meters of substrate and many liters of material, plus meters and meters of ovens to dry your coated layers. And they're not really designed for easy adjustment of experimental parameters. So if you're a small or medium scale researcher, you're going to have difficulty repeating your experiments, and chances are you'll probably blow through most, if not all, of your research budget just by turning one of these things on. So over the years then, people have logically tried to shrink down this technology into a mini roll-to-roll form factor, which is certainly a reasonable next step. But these machines don't quite hit the mark in terms of effective research tools either, in our opinion. They still require full substrate rolls, which is not particularly compatible with a typical lab scale workflow. They're not particularly sensitive in their adjustment of experimental parameters. And in order to make the machine smaller, often these machines will either shrink ovens below a point of usability or forego them altogether, meaning that it's very difficult to actually dry the samples that you produce, and you risk winding up with a wet or smeary layer that is collected at the rewind roll, which can sort of defeat the purpose of an experimental sample production tool. And these are the challenges that we're trying to overcome at our company. So we're working to bring the benefits of slot die to the R&D environment without the drawbacks of bulky equipment. Our tools work with convenient lab scale substrates like A4 sheets and M12 wafers. They work with standard disposable lab syringes and require just a few milliliters of solution to get started. They've got built-in hot plate heating, so you can dry your sample without requiring large ovens. They fit easily into a glove box or fume hood enclosure if that's a requirement for you. And they're operated with a simple touchscreen interface that gives you great control and repeatability of your experimental parameters, meaning that you can do process development scientifically rather than, in a guesswork process. Here you can see a lineup of our standard tools next to a friendly scientist for scale. And we're of course happy to chat about these at our booth if you're interested. And we also wanted to share an example from one of our corporate clients who are using our large scale slot die hardware to produce polymer foils with an average thickness of 85 nanometers and a standard deviation below 5% over an area of more than 3,000 square centimeters to drive their commercial process today. This product was developed on our lab scale research tools and has now been scaled up to a full commercial process. And that's very exciting for all of us. 1 minute, David. Yeah. If you're interested in getting started with slot die, but you're not sure how, we've also partnered with universities around the world to offer demos, training, and workshops based on our tools, which we're of course happy to coordinate for you. And we're delighted to be bringing these benefits to you in partnership with Inseto, our official UK distributor and partner here at InnoLAE 2021. So thank you very much for your time, and we hope you'll drop by our virtual booth in case you've seen anything that interests you.